Hey Gems, it's Miss Damaso. We're going to get started on our week 6 video 1 notes. It is Thursday, so we only have one video this week because obviously earlier this week you guys took your quiz, so this is the only video that you're going to have for this week. Just like usual, you can find both the notes and the homework within the Edmodo assignment, and you're welcome to print them off and do the notes with me, or you can do the notes on your own. So let's get ourselves started. We're talking about chapter 10.5, tangent lines, and we're going to jump right on in. So we've already talked a little bit about circles and some segments that are inside of a circle, segments that are outside of a circle. So we're going to continue talking more about circles today, but now we're going to just talk about tangent lines that are on a circle. So let's get started with our definitions here. So a tangent line intersects a circle at exactly one point, and we call that point the point of tangency. So if you look over here at my circle, the tangent line that goes through this circle, the point of tangency is the one point that touches the circle. So my point of tangency is this point A right here. So that's in my picture there. A line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. Okay, now remember, perpendicular, I think you guys probably all remember when I'm holding my hands up in front of you. Parallel is straight, it's two lines that are never going to touch. Perpendicular is when they cross and they make a 90-degree angle. So perpendicular means you have to create a 90-degree angle. And if it is perpendicular to a radius, so a radius goes from the center to the edge of a circle, then the line is tangent. If it is a right angle here, then what you're going to end up seeing is these 3 points, I can turn them into a right triangle. And then we're going to be able to solve some of the unknown side lengths of that right triangle using the Pythagorean theorem. So for each of our problems here, we're going to determine if line segment AB is tangent to circle P. In order to be tangent, this line A to P has to be a right angle. And if it's a right angle, I can use the Pythagorean theorem to solve for the side lengths. Now, I'm given all of the side lengths here. Here's my radius right here because it goes from the center to the edge. So this is my radius, this 8. That means my right angle should be over here that attaches to the radius. So remember, if I use the formula a squared plus b squared equals c squared, right? If that's what my theorem is, right? That's the Pythagorean theorem. The A and the B are the legs of the triangle, and the C always has to be your hypotenuse. To find your hypotenuse, you're always going to go across from the 90 degrees. Okay, so if you find where the right angle is, go straight across from it, that's going to be your hypotenuse. So in this picture here, if I go find my 90 degree, I go across from it, the 17 is going to be my hypotenuse. That's what I'm going to plug in for C. So let's just plug in our numbers here. Oh, I really should have grabbed a calculator. Okay. A squared, so that's just one of the side lengths, so that could be, it doesn't matter which one you do first, 8 squared, plus b squared would be 15 equals c squared is my hypotenuse, it's 17. Okay, and now I'm just going to go through and solve and make sure that it's true. So if I do 8 squared, I get 64. If I do 15 squared, I get 225. And if I do 17 squared, I get 289. If I add together 64 and 225, I get 289, and 289 is equal to 289. This is a true statement. So yes, line segment AB is tangent to circle P. So my answer here is yes. Okay, let's do another one just like it. Number 2. Again, first thing you should try to find is your right angle. So I'm going to look for my radius right here. Here's my radius, 11, so that means this is where my right angle is. My hypotenuse is directly across. Now, what you're going to notice is I only give you this small piece out here of 5. I don't tell you what the whole side length is. However, I know that this line right here, A to P, is a radius and it's 11. I see another radius on my picture. The other radius, again, goes from the center to the edge of the circle. That means this piece over here is also 11. They're both radiuses, or radii, excuse me. And so, what I can do is I can say, all right, if this is my right triangle now, one of the sides is 11, one of the sides is 14, my hypotenuse that's across is a 5 plus 11, which is really 16. And now I'm going to plug in my equations into the Pythagorean theorem again. So I've got one side is 11 squared, plus the other side, the other leg is 14, equals my hypotenuse, remember, is this whole side, 5 and 11, so it's 16. And now I'm just going to go through and check it and see if my numbers are correct. So 11 squared is 121. 14 squared is 196. 16 squared is 256. Okay, if I add these two numbers up together, I get 317. And then I say 317 is not equal to 256, so that means this line AB is not tangent to circle P. So my answer here is no, it is not tangent. Okay, now for the next problems, I'm telling you that line segment JK is tangent to the circle, and I'm asking you to find the unknown side x. So we're still going to be doing the same sort of thing. We're going to be setting it up using the Pythagorean theorem, but this time I'm telling you that they are definitely tangent, so you just have to find the unknown side length. So let's get started with number 3. First thing I'm going to look for is my radius. My radius goes from the center to the edge, so this right here is my radius, which means that this is where my right angle is. That means across from the right angle is my hypotenuse. So this side x is my hypotenuse, and these two are my legs. So now I can plug them into the equation. A squared plus b squared equals c squared. So my two legs are 7 and 19. And my hypotenuse is what I'm trying to solve for, which is x, so I'm just going to leave it as x squared. And now I'm just going to go through. 7 squared is, so 49, I don't know what 19 squared is. So this whole thing is 410, I do know that, equals x squared. So give me 1 second. I'm going to go run and get a calculator. Things I should have thought before I started videotaping. I apologize. Okay, so 7 squared was 49. And then 19 squared is 361. Okay, so that's where I got 410 from. Okay, so I've got 410 equals x squared. Now, to get the x by itself, I have to get rid of the squared, so the opposite of squaring something is square rooting it. So I'm going to put the square root of 410 into my calculator, and I get approximately, so make the approximate signs because I'm going to round it, I get about 20.2. And there's my answer. make sure when you're putting it into your calculator, if you're going to use your phone calculator, you put the number in first, and then I believe you have to push either a shift button or the second button on your calculator, and then you're going to click the square root. Make sure it has the little 2 next to it. That means it's a squared root. If you're going to use your phone for it, make sure too that it's turned on. You have to turn it on its side, so you have to turn the portrait mode off of it. All right, number 4. First thing I'm going to do is find the radius. So the radius goes from the center to the edge. So this is my radius, 11, which means this is where my 90 degrees is. Now, I've got one side length is x, one side length is 11, and I need to know this entire side because this whole side is my hypotenuse. Now, I only know that from this point on the circle to this point K, I know that that's 7. I don't know what this piece is over here. However, I see it goes from the center to the edge, so this is also a radius. So if this radius is 11, that means this radius is 11. So the whole side length, if I walked this whole distance, I would walk 11 steps and then 7 steps. That's a total of 18 steps. And now I'm going to use those numbers in the Pythagorean theorem. So I've got my 2 legs. My hypotenuse is this 18, so I'm going to label it so I don't forget. And I'm going to set up my equation. So I've got 11 squared plus my other leg is x squared equals hypotenuse squared is 18 squared. Okay, 11 squared is 121. And then 18 squared is 324. Now to get the x by itself, first thing I'm going to do is I'm going to subtract 121 from both sides. So I get x squared equals 203. And then to get that x by itself, I'm going to square root both sides. So if I take the square root of 203, I get approximately, so I'm rounding, so I don't put the equal sign, I'm approximately saying it's about 14.2. Okay, a couple more like that one. Number 5. First thing I'm going to look for is my radius. So my radius goes from the center to the edge. That's the 10. So I see that this radius right here is 10. That means the 90 degree is here. I see another radius, which goes from L to this point right here. So I know that this piece also must be 10. And then I know that this whole side is across from the 90, so this whole thing is my hypotenuse. Okay, now, here's where I have a little bit of a problem. I don't want to know the whole hypotenuse, I just want to know one piece of the hypotenuse. So instead of calling this 10 plus x, which I could do, I'm just going to call this whole side y. I'm going to show you why I'm going to do that in just a moment, because then I'm going to be able to figure out what this one piece is. First I'm going to find the whole thing, then I'm going to find just the one piece. So I'm going to set it up the same as before. I'm going to take the 2 legs, which are 24 and 10, and I'm going to square those two. 10 squared and 24 squared. And I'm going to set that equal to y squared. I'm going to figure out the whole hypotenuse first. Okay. So 10 squared is 100. 24 squared is 576. If I add those two together, I get 676. And then to get the y by itself, I square root both sides. So I end up getting the square root of 676, I think is, 26. So 26 is this entire hypotenuse, right? Now, I know that this piece x plus the 10 should give me 26. So if I add x and 10 together, I should get 26. So to figure out what x is by itself, I'm just going to subtract 10 from 26. And I end up getting that x is equal to 16. So 16 plus 10 gives me the whole side length of 26, which is what I solved for. And now I figured out just this small piece x right here. And I'm done. Number 6, same sort of thing. First thing I'm going to look for is my radius. Now, what I notice is I am given a diameter. I'm given the whole thing. I'm given that this one piece from from L to J is 11. That must mean that this piece from M to L is also 11. If that's where my radius is, here comes my 90 degrees. It's off of the radius. Across from the 90 is my hypotenuse. So the 25 is my hypotenuse. This whole side length is 11 plus 11, which is 22. So now I've got one leg is 22, the other leg is x, my hypotenuse is 25. And I'm just going to plug it into the equation. So 22 squared plus x squared equals hypotenuse squared is 25 squared. Now I'm just going to go through. So 22 squared is 484. And then 25 squared is 625. Now, to get the x by itself, I'm going to subtract the 484 from both sides. I get x squared equals 141. And then to get the x by itself, I square root both sides. And I get, that's going to give me a decimal, so I'm going to put it in my calculator. I get that x is approximately 11.9. It's 11.87, right? So I round up that 8 to be a 9. All right, one more like that. Number 7. Again, I'm given, here's a radius right here. That must mean that this radius over here is exactly the same, so it's also 3.5. That means this whole side, if I were to add 3.5 plus 3.5, I would get 7 for the whole side. Because this is where my radius or diameter is, that means this is where my 90 degrees is. So I've got one side length is 7, or one leg. One leg is 6.4. And my hypotenuse across from the 90 is x. So I'm just going to plug those into the equation and I'm going to solve for it. So I've got my two legs, 7 squared plus 6.4 squared equals my hypotenuse squared. Okay, now I'm just going to go through and square them. 7 squared gives me 49. 6.4 squared gives me 40.96. If I add those two together, I get 89.96. And then to get the x by itself, I'm going to square root both sides. And if I square root, I get approximately 9.5. So when I put in my calculator, I really get 9.48. But again, if I round to the nearest tenth, the number afterwards is bigger than a 5, so I round the 9.4 up to a 9.5. All right. Okay, just a couple more. Next section here. More tangent line properties. Let's zoom out a little bit so we can see. All right. If two segments from the same external point are tangent to a circle, then they are congruent. So if I have a point that's outside of the circle, it's external, the two sides that share that same point are going to be congruent to one another. So this side AB is going to be exactly the same as this side CB. They are congruent. They're going to be exactly the same length. So if this was 10 inches, this is 10 inches. Number 2, if a polygon is circumscribed around a circle, then all sides are tangent. So that means if I have a triangle and the circle touches the 3 segments at 3 different points, it has to touch at 3 points of tangency, that means all 3 of these sides are tangent. So that would mean DB and BE are exactly the same. EC, I'll do a different color here, EC and FC are exactly the same, or congruent, and AD and AF are also congruent. So whichever point that they share, those two sides that share that same point are going to be congruent to one another. So it's almost like I've got 3 little like party hats. So the two sides that make up the same party hat are going to be exactly the same. It's kind of how I think about it. All right, so for each one, we're either going to find each value or measure, and then we're going to assume that the segments appear that appear to be tangent are tangent. So if they look like they're tangent, we're going to assume that they are tangent. So we just have a couple problems here. Number 10. I've got a point out here that's external, point B. I've got the two sides of the party hat that are tangent to this circle, so that means side AB is congruent to side CB. So because they are congruent, that means they are exactly the same. So since they are the same, I can solve this by just taking these two equations and setting them equal to each other. So I'm going to do 8x minus 19 equals 5x plus 23. And then it's just a normal algebra problem that I know how to do. So first thing is I'm going to get my x's together. So I'm going to subtract 5x because it's the smaller one from both sides. I get 3x minus 19 equals 23. I then move all my constants together, so I add 19 on both sides. I get 3x equals 42. And then to get the x by itself, I divide by 3. My answer is x equals 14. And that's it. So if there are two sides that they're two segments that have the same external point and they're tangent to the circle, so they're outside, they only hit at one point, then these two side lengths are going to be exactly the same. They're congruent. So find PQ. This one looks very similar. I've got the external point that they share. I've got two segments that are tangent. They only touch the circle at one point, so that means these two side lengths are congruent. So PQ is congruent to RQ. And again, because they are congruent, I'm going to take those two equations and I'm just going to set them equal to each other and solve for x. So I've got 14x minus 13 equals 8x plus 5. And it's an algebra problem. So the first thing I'm going to do is I'm going to subtract 8x from both sides. I get 6x minus 13 equals 5. Then I add 13 on both sides. I get 6x equals 18. I divide by 6. I get x equals 3. Now that's great, but the question asks me to find PQ. So I'm going to come over here to PQ. And wherever I see an x, I'm going to substitute in the number 3. Okay, so now I'm substituting. 14x minus 13. I'm really going to do 14 times 3 and then subtract 13. So 14 times 3, 42. I subtract 13 from it. I get that PQ is equal to 29. So make sure you're reading what the question asks you to do and you're following all the directions so that you answer the question completely. All right, we're skipping number 12. We got our last two here. Find the perimeter of DEF, triangle DEF. So I want to know perimeter means if Miss Damaso was to start at point D and she was going to walk all the way around, how many steps would I walk to go all the way around? So perimeter is like a fence. Okay, so now I've got a polygon, which is my triangle, that is circumscribed around a circle. That means all of my sides are tangent. And if my sides are tangent, then if they share the same point, they are going to be congruent. So that means this. If I start over here at point E, the two sides that touch this point E are HE and IE. That means these two are congruent. So if HE is 16, guess what? IE is also 16. I have another set. Here's another point, point D. I've got DG is one side of like the party hat. The other side of it is DH. They both share this point D. So that means this side, DG, is the same as this side, DH. So since DG is 11, that means this side, DH, is also 11. Last one, I'm sure you can tell here. Point F is external. The two sides that share point F are IF and GF. That means these two sides are congruent. So since this side is 9.5, this side is 9.5. Okay, to find the perimeter, I'm going to add up all of the numbers that are on the outside. I'm going to add them all together, and if I add them all together, that should give me my perimeter. So I'm going to add 16 and 16, the two blues, plus the two greens are 11 and 11, plus the two pink ones are 9.5 and 9.5. So you can add them up like that, or you can do 2 times each number and then add those numbers together as well. Either one works. So plus 9.5. Okay, so if I add them all together, right, my perimeter of triangle DEF is equal to 73. And I don't have a label, so I can put 73 units. If you're not given anything, they're not given inches, centimeters, you can just put units there. All right, last one. Number 14. Find the perimeter of quadrilateral PQRS. All right, so again, this time it's very similar to the last one, but instead of it being, instead of being a triangle, it's now a quadrilateral. But the same thought process still applies here. Now, I am given a couple different things. I'm going to start by marking all of my sides that are congruent. So if I look out here at this point P, I'm going to mark my two sides that share that point P as congruent. Boop, boop, tick marks. Same with my Q. Same with my points that touch R. 3, 1, 2, 3. And then same with my 2 points that touch S. Right, so that makes it easier for me because now I can already see some things that are exactly the same. I already see that this side's 23. That means that this side must also be 23. I see, I don't have anything for the green, but I do see in the blue that this side over here is 27.1. That must mean that this side over here is 27.1. Now, I don't know the pink ones and I don't know the green ones. But here's what I do know. I know that this whole side length from P to Q is 37.5. I already know that part of it in orange is 23. So 23 of the 37.5 is already used up. To figure out what's over here in the green, I'm going to take 37.5 and I'm going to subtract the 23 from it. And that'll tell me what's left over right here for this one green piece. If I do that, I get 14.5. So I know this piece is 14.5. I know this piece is 14.5. I'm now going to do the same thing for the pink. I know this whole side is 52.5. I already know this one blue part is 27.1. So to figure out what the piece over here, this pink piece that's left over, I'm going to take 52.5 and I'm going to subtract 27.1 from it. And when I do that, I get, I need to do that on my calculator, 0.5 minus 25.4. So this piece is 25.4, this piece is 25.4. Okay. Now, for the perimeter, I'm going to add everything up together. So you can add double of the orange, double of the green, double of the blue, double of the pink. Or if you want to add just this side plus this side and then add these two and these two. They're all going to give you the same thing. It doesn't matter how you go about it, but you do need to add up every single number that is there. So I'm just going to write it out. I'm actually going to write it out right above it, just because I'm kind of running out of space there. So to find my perimeter, I'm going to do 23 and 23 plus my 2 in green, 14.5, 14.5, plus my 2 in blue are 27.1, and then plus my 2 in pink, 25.4. Okay, so you can add them all up like that. You can do 2 times 23 plus 2 times 14.5 plus, right, and go on that way since there's 2 of each one. However you want to add them up doesn't really matter. It's just whatever kind of works for you. I like to add up each one individually because if I do it that way, I know I'm not going to miss anything. And I like doing it in multiple colors too because I think that it helps me out just a little bit. So if I add up all those numbers together, my final answer is that the perimeter is equal to 180, and I don't have anything, so I'm just going to put units. Okay, and that's my final answer for number 14. Okay, so we are now finished with our tangent line notes. So these were just the 10.5 notes. You can now go back into the assignment. You'll find your 10.5 homework that goes along with it. A couple questions that look very similar to these. They will be due on Monday at 11:59. Make sure you turn in them on time. You have Thursday, Friday, and the weekend, so that is more than enough time. If you have any questions, please reach out to me on Edmodo. Otherwise, I hope you guys have a great day and make sure you turn in that homework and show all your work. Oh, and additionally, make sure when you're turning in your work, you turn in your work itself, a clear picture of it, and a clear picture of you holding your work. That's the only way that I know that you did your own work and you didn't copy from someone else. So please make sure you do both of those, otherwise you will not earn any credit for this homework. Okay, so thanks so much. Have a great day, and if I don't hear from you, have a great weekend as well. All right, bye guys.